Hey, it's Alex with Blind Car Garage. I hope everyone's having a great day today. Been a little busy lately with personal obligations, but I figured I'd do a video today about some things that have been on my mind because my mind never stops working. But you guys remember the K-Jet that we did, and that was kind of a learning experience for me too. I was not super familiar with the K-Jet Tronic setup. There are some other variations as well, but it's known as a constant injection system. That means it's always flowing fuel. Now, I was thinking about it. What is an easier way that I could do this on a custom vehicle or a custom design? Because let's face it, aftermarket fuel injection systems are outrageously priced, truly. And I ain't got that kind of money, but I've got some ideas. Um, Not all of those are CIS, and some of them are for the aftermarket stuff. But let's expand upon the K-Jet idea. First of all, you've got the distributor. It has 8 lines coming off the top of it, one for each mechanical injector, which literally it's a straw basically with an injector atomizer nozzle at one end and a check valve in there that has a spring tension, and it opens at 58 psi. Now, it shuts once it drops below 58 psi. Now, basically what that means is that you've got constant flow through those injectors while that pump is on. Now, to modulate based on throttle, because you've got to keep a mixture of 14.75 or whatever it may be for your particular setup to one, which is the one being the fuel, the 14.75 being airflow. Now, what they did was they had a throttle body with throttle blades that opened and closed like a standard throttle body. They had the injectors run as we've spoken about. Now, in between the throttle body on one side, and then there's another thing that looks like a throttle body that's in line between that and the air filter. Now, that second one is interesting because you have the fuel distributor right behind it and it's connected with leverage. Now, what happens is there's a plate in there that uses vacuum to hold it up, all right? And when you give the vehicle gas, you open the throttle blades, which an engine is an air pump. It pulls more air and pushes that uh, plate down, which is kind of like a flap, if you will. And what happens is as it goes down, it uses leverage to increase the volume, not pressure. Pressure is constant. The volume of gasoline moving through the fuel distributor. Now that's all 8 injectors all at once, constantly. There is, you're not using pulses. There are no pulses. This is flow rate is all that controls. Now that's the basics of it. It's a little more complicated, but not by much. All right. What we have here is a 2000 Mustang. All right. It is the 5 liter, but it actually does not really matter, and I'll tell you why. All right. It uses something that is very great. It's a modular Bosch injector. Now, many things use Bosch style injectors. It's got 2 connectors, and then it's got a input and an output. All right. The output having the atomizing nozzle on it. Now, what happens is these in this car are pulsed. All right. If you need more fuel, it pulses less. If you need less fuel, it pulses more. All right. Now, there's a different style of injector that does not use pulse. It is a basically these injectors are 1 and 0, on and off. There is no between, there is no variable spray rate. But again, the pressure is still constant. Now, my idea is this. All right. It would take a little bit of tinkering, but I'm going to do an experiment with it on that old lawnmower I have in the backyard. I kind of want to see what it's like, what I can do with it. All right. First off, you start with this. There is an injector very similar to the Bosch style, but for a custom build, you're really only limited by what you can make work. Mechanical injectors are also a great idea and would work perfect for this. All right. But let's go back to the electric injector. It has 2 wires, a power and a ground. All right. Now let's design this for a single engine setup for the a single engine 2-cylinder setup for sake of conversation, all right, you got two injectors, one on each cylinder. All right, you've got, let's say, we'll do a lawnmower engine. It's got a little coil, and there's a magnet on the flywheel, and it's got two coils. And when that magnet passes, that is advanced of top dead center of that particular cylinder to which it is connected for spark. All right, so it's not going to fire unless that has power. And this would translate well over to distributors too, because that little needle in there pointing to the wire, if it ain't pointing at that wire ain't firing. All right, so we've got that taken care of. All right, now let's say you take a T fitting. I would use brass personally. I like brass. All right, it handles fuel well. All right, this would be a T fitting. Use steel lines coming up and dividing into the two different injectors, one for each cylinder. Now, to find the injector you're going to need to do a little bit of math. This is 4.6 liters. All right, it's an 8 cylinder. So that's 4.6 liters divided by 8. Then once you have divided that, you now have the um, the flow rate of that single injector per cylinder volume. So um, let's say for sake of conversation, because I don't feel like doing super hard math right now, you've got an 8 liter. Let's say 496 big block. All right, it's 8.1 actually, but a little bit.